So yeah, I'm going to cover P2P apps for the web. First, just a little bit about me. My name is João Antunes. I'm a software engineer at YLD. I'm a master's student at Técnico, and there's my handle for Twitter and GitHub if you want to check, speak with me, I don't know. So let's start with the basics. What are P2P apps, or what are decentralized applications? Let's start, so bear with me. I'm going to make an analogy along this talk, which is with an office. So imagine you're in an office. You have this tall building full of workers, and every time you need a document, whatever that be, you need a document, you need to go to the 22nd floor, get that document, go straight down to your desk, for example in the first floor, and then do your work. And then you realize, oh shit. So turns out this document needs another document, which I need to go fetch right now. So I go to the 22nd floor, I get that document, and I go straight down. And meanwhile, your coworkers around you, you don't interact with your coworkers. So this is a really corporate environment. You don't speak with anyone, okay? So meanwhile, your coworkers are doing the same thing, getting the same documents, and going to the 22nd floor without you speaking with them. Nobody speaks with one another. Going to the 22nd floor, getting the same document, and going down to the first floor again. So yeah, really cool, right? So meanwhile, you think, well, this could be different, right? So we all need to go to the 22nd floor to get documents. That's for sure. It's the document hub. It's where all the documents are produced and stored. But we could share with each other, right? So if my colleague over here is getting the same document, why do we both need to go to the 22nd floor to get that document? If he already has it, I just go fetch it. It's right here. So with this weird analogy, what I was trying to show you was a really simple gist of what it is a centralized application versus a decentralized application. So in a centralized scenario, you have this hub where all communication flows through. So if you're going to, if you're accessing Amazon, if you're accessing Wikipedia, if you're accessing, imagine whatever website you're accessing, if all of us in here were accessing that same website, we'd all be making different requests to get that same document, the same content. And still, why would you still consider decentralized or P2P applications? So let's go back to the office, the good old office. So imagine you're in the first floor, you need to go fetch documents from the 22nd, but there's only one elevator, right? So, and that elevator has it's a big elevator, enough people are able to fit in there, but still, it's kind of cramped. So, whenever in a busy day, a lot of people are going to the 22nd floor to get documents, sometimes not everyone fits in there, and people start waiting around to go in the elevator to the 22nd floor to get documents. And then someone else in the office thinks, oh boy, I don't need a document, I need these 6 boxes of documents, and I need them all right now. So he goes to the 22nd floor, and he fills the elevator with boxes, and nobody else can go in the elevator with him, so the lines start piling up. So what am I trying to do here? I'm trying to explain you the concept of bandwidth. So right now, all of us in here, if we're accessing the content I was telling you before, whether it be Wikipedia, whether it be, I don't know, Netflix, someone who's trying to stream something, we're all going through this tiny channel, which is the broadband that's going out of this office to get, again, the same content to all of us, but through different connections. And you start to think okay, that's we have our gigabit connection over here, we're cool, right? Well, yeah, if you go to somewhere where you have flaky connection, or if you go to somewhere not the main hub, if you go to the countryside, you probably regret that everybody in a single room is trying to fetch the same thing and nobody can get it because everybody is cramming and like screaming for more bandwidth. If you're still not convinced, like there's also the political, like kind of political aspects to it. So there's a trend towards internet gatekeepers. There's of course like all of the privacy and data storage concerns that even like for the past few weeks have been like nobody has been talking about anything else. Suddenly everybody realized that people are out for our data. And yeah. Centralized solutions are also like more susceptible to political pressure, like it's true. So if you picture it, like probably, like if not all, like a big chunk of our data resides like in the United States, and the current political scenario could be better, let's say like that. So imagine that like from one day to another the government decides to seize like all the data centers that are over there, and suddenly you don't own your data anymore. Like you never owned it, but yeah. There's also like, if we're like going to speak in technical terms, there's also like the issue with scalability. So whether you like it or not, it's much harder to scale like a centralized application you could instead of a centralized one. So well, you might think, yeah, but I go to AWS and I like just spin out, like I just go to the form and suddenly like I have like more instances of stuff running. Yeah, but you probably still have to manage it. You're paying a shit ton of money for that to happen. And take into account that like, so AWS was like, AWS and all the other cloud providers has been like the pinnacle of like centralized application development. Like we have been working for 40 or 30 years and eventually came with something that kind of reduces the management you need to do, but you either have to pay like a shit ton of money or you have to have like a full-time team working on the clock to solve issues with your applications. If you're still not convinced, so imagine like being able to work when you don't have GitHub and when you don't have NPM, and Slack is discussable. I would say that you'll probably be able to work more if you're not sending GIFs, but it's discussable. It's still like, you need to talk with your team, so yeah. So let's start by defining the basics. Like what do we need in order to like have a peer-to-peer application? What are the minimum requirements? So the peers need to communicate freely, of course, right? And we'll need to keep some sort of distributed like network state. I need to know which peers should I contact in order to get wherever or search for more peers. And of course, we need to like to insert and retrieve data from our application, right? So let's go back to the office, that top of the notch office. So they just got an upgrade and they got telephones for all the floors, right? So like right now, instead of you, like sometimes happened, you would go to the 22nd floor to get a document. Turns out they didn't have the document, so you made like a useless trip. So now you have like a phone where you can ring the 22nd floor and ask, do you have the document? And they'll probably say, yes, we do. So you go up and you go get the document, which is cool, right? Like nice upgrade. But the thing is, so that like there's this phone for each floor, and you can basically only reach the 22nd floor. You could reach the other floors if you want to, but who would you talk to? You don't know anyone, right? So if we're trying to make you like more collaborative with your peers, would you be able to ring your peer, like call your peer? Probably not, right? So you have to figure out where in which floor is your peer to start with. And then when you ring to that floor where nobody knows each other, you need to like get someone to find whoever you need to speak with. So this, my friends, is what we call NET. So turns out there's this thing called network address translation, right? That is basically like instituted like in every domestic installation of internet. Every connection you have basically usually is behind the net. So why? There are like a lot of reasons. If you're in a corporate environment, you'll probably have a net for like security reasons and stuff. But usually these turn out to be like quite famous when the IPv4 address exhaustion started to pop up, and we didn't have enough IP addresses to represent like all the computers and devices that were connected to the internet. So we need like something that would stay in the middle. So we have like this public IP address for this building, for example. Everybody can like reach out to that IP address, but they can't reach out to any of us directly, right? And we can reach to outside, like we can make a request to a server with clients, right? We can make requests to a server because they do have like an IP address, and stuff works, right? Yes, stuff works when you like in a client-server model, but when you're trying to achieve like peer-to-peer communication, stuff gets messy. Like you can't reach out to your peer, which is like in the other building or near you. So, are there any solutions to this? Fortunately, the office, like this amazing office, has a solution for this problem. So, we have like phones in each floor. Cool. And we all know the 22nd floor, the almighty 22nd floor, right? So maybe we can ring to the 22nd floor and maybe ask them and say like, look, I need to find Bob from accountant, and like I need to get this document to him, right? And like they the almighty 22nd floor, they receive like connections from all over the building, so they know where Bob, in which floor Bob is, and like they can probably reach out to Bob if needed be. So they send a person to you to get that document, and then that person goes to the floor where Bob is and delivers the document. Nice. So now you're able to communicate, right? Although like this is what we call relay communication, because you're still relying on the server, like the 22nd floor, in order for you to communicate. So this is what happens when you, I don't know, like any messenger app or like chat application. Usually what you do is, if I want to reach out to my peer, what I do is send a message, and eventually in their server they're going to route the message to that peer. So it's not that much peer-to-peer, right? Communication flows in between like these servers still. But fortunately, the office has another awesome invention that could solve this. So if you go back to the office, and we can like start to think a bit. So we still have the same setup, but what if instead of like they send me a person from the 22nd floor to get the document, and then that person goes to the other peer to deliver the document, what if they told me like just where Bob is, and I can go there myself, deliver that document, and get back? Or even they can tell me how to reach Bob, like which floor should I ring to, and what do I need to tell to the other side in order to speak to Bob, because Bob also has a phone on his side, and he probably keeps ringing 22nd floor all the time. So they probably know each other, and when that happens, I'm able to communicate with Bob freely because I know where he is, I know how to reach him, so I don't need the 22nd floor anymore. Like I officially know Bob, I can do whatever I want. So this is what we call like net hole punching. So the concept is you have this like this third party where like every single peer knows this third party. So what you do is you reach out to him, and the other peer reaches out to him, and this third party knows how you can speak with all the peers. So all you need is to retrieve information from this third party and then start streaming information between the peers. What happens is that you're kind of like tricking the net. So you're kind of tricking your router because your router thinks you open the connection to like this third party just to like get some client server data, and then you open the connection to your peer, you think, oh, it's another server. It actually isn't. And you're able to stream data between these peers, and you eventually drop out the third party because you don't need it anymore. Cool, we're able to communicate in a peer-to-peer fashion, right? But like this whole setup doesn't sound like much P2P-ish, right? So the truth is that net traversal and net traversal techniques highly depend on the type of net you're behind of. And the hole punching techniques mostly work in most of the scenarios, but there are still some edges that need to be trimmed. But the truth is, after you have like a small network setup, you don't need like this 20-second floor or this third party or this server that every single peer knows. No, in fact, all the peers in the network that are already connected can act as like rendezvous nodes for whoever wants to join the network, and they do the job of the server, the 22nd floor, right? Okay, cool. So now that we've set up this, we're able to communicate. So how are we going to keep like the state of the network? How am I going to know which peers should I reach out to if I need to communicate? Let's go back to the office. So ideally, I don't want to think like in which floor every single peer that I keep connections with is. I don't want to think in which desk he sits. I just want to know him. I want to have like a point of contact to him. I want to reach out to him whenever I need because I need some special documents and he probably can deliver to me, right? So this is like a key property, and like this is a key requirement. Not a requirement, you can do it without it, but it's a major improvement in peer-to-peer apps, which is the creation of a network overlay. So the idea is you create a logic abstraction from the actual physical network. So you aren't restricted to where you are or like what kind of network you have running. What you want to do is I have this network that represents my my peer-to-peer network. Does it have any sense in the physical network world? Probably not. But it abstracts me of all this of the burden of dealing with this, and I'm able to establish connections however I want, right? So cool. What can we do with it? Like, so we want to build like this overlay network structure on top of this. What can we do with it? So if we go to the office, how could we achieve something like this? Well, like imagine like in the office, all employees have employee numbers, right? So it's such an amazing office. I mean, employee numbers, 22nd floor, you'd love to work there. So imagine like all of them have numbers, and what you do is simply order them in a specific setup, order their desks in a specific setup, so that when peer 1 needs to reach out to peer 8, he knows that if he reaches out to his left, eventually a request will land in peer 8 or in peer 4, like it's possible, right? So if you have like this specific structure and everybody obeys this structure, you're able to establish a way of communicating reliably. So this is the concept of a structured overlay, and a specific set of these structured overlays are DHTs. So DHT is nothing more than like a distributed hash table, of course, but a way to address peers and content in a structured manner. So you could like have a ring, for example, or you could have like space where you represent like your peers as points in that space. This is kind of like an abstraction of what is actually happening below, but the core idea is this. Like a lot of popular solutions use ring DHTs. Has anybody ever heard of Cademlia? Like from the Blowfish era, there were like, probably not, okay, cool. But there are like a lot of solutions that use ring-based DHTs. Cademlia is one of them. They're scored. Like there are plenty of solutions out there that do this. But like, is this the only possibility? No. So imagine you don't want like any structure in your office, right? You don't want to like say people you have to have your desk over here and you need to be sitting over here. So instead, you have like this small network of peers. So like I know 2 or 3 people. I know that I can reach out to them whenever I need something. So imagine I'm looking for Peter from HR. So I reach out to someone to ask for Peter from HR. And they may know Peter or they may not. If they don't know Peter, just say, oh, just try Janice over here. She may know him. I don't know. So this is an analogy for like a structure overlay, which usually relies on gossip communication, right? this gossip communication is like exactly what's happening here. Like it's gossip. You're trying to reach out to someone and speaking with a lot of people, which in that term like speak with other people. And it's a probabilistic approach. You may never find Peter from HR, and you won't be 100% sure if was he fired, was he not, is he still in the building, is he not? I don't know. I won't be completely sure until I run through every single peer. But I won't be needing to be fixed in a specific structure, right? So with this in mind, how do I retrieve and store data? So like these structures I was telling you about were like all about keeping the network, right? But the thing is that they for free give you the access to retrieving and storing data. So if you have like a DHT and the function you use to like hash every single one of your peers uses to store content, you imagine you have a document and you use an hash function in that document, it will return 2. So what you do is, all right, this function return 2, I need to store it somewhere, I'll store it in the nearest peer to that function. You'll store it in 1. So it's basically the same concept if you wanted to say like, if you went like in alphabetical order between like all the peers incrementally and like every single one of them would store like, I would store all the entries that start with A, I will store all the entries that start with B. So whenever I needed to look for something that starts with B, I know that I should look on that side of the DHT, right? And the same happens in an unstructured overlay, right? So instead of asking for Peter from HR, you just need to do you know where docx is, and probably tell you like, probably Janice, try Janice. Yeah, Janice is like the go-to person in the office. So you're probably like this right now, like so much stuff happening, I'm already sweating. So let's take a step back and think, because in reality, I wanted like to give you an analogy of what it is like a peer-to-peer application at its core. But the reality is that you don't need to deal with all of this if you don't want to. I'm going to speak with you about Leap peer-to-peer and IPFS. So IPFS is a peer-to-peer hypermedia protocol that creates designed to create persistent content addressable network for the web. So with that in mind, erase it, and this is the version I like it best, because for me it's just a set of primitives that allow me to build peer-to-peer applications. Why is that? So IPFS, as a DHT said, built in it, and you can interact with it if you want. You're able to store and retrieve content in a normal fashion if you don't want to deal with the DHT. It deals with all the transports for you, so imagine that, I don't know, like someone over here is trying to reach out using WebSockets or WebRTC, and you have a Raspberry Pi at home that uses preferably like TCP and UDP protocols. IPFS manages to bring all this together like into a single module. And on top of this, you can build like whatever you want. And I like to say this set of primitives even because like in the last year, IPFS released an experimental feature which is PubSub. So imagine like PubSub. Is anyone here not familiar with the concept of PubSub? Don't be shy. Okay. So PubSub essentially is imagine you like subscribe to a magazine, for example. You have this source that is producing content to you, but you, as a subscriber to this content, whether it be a magazine, whether it be a journal or whatever, you just receive it like monthly or weekly or whenever there's new content for you to consume. And this source doesn't know who you are, and you don't know who the source is, probably, like you know that's maybe like a beauty magazine or something like that, but you don't know more than that. And it's like highly used for stuff like games or chat applications. I mean, like a lot of stuff. And they now have this feature built in into IPFS. And if you're still thinking like, okay, IPFS, but it looks like a big chunk of, it looks like it does more than what I need. That's true, right? And that's why beneath IPFS, there's lib peer-to-peer. So lib peer-to-peer is this cool, awesome project, which basically gives you a modular network stack that you can use like however you see fit. So if you go to implementations, oh, by the way, IPFS has both Go and Golang and JavaScript implementations. The cool thing about the JavaScript implementation is that it doesn't only run on Node, it also runs on your browser. So you can actually run like a IPFS node in your browser and be able to communicate like peer-to-peer communication in your browser. But I was telling you about lib peer-to-peer, which is quite cool because it abstracts you like a lot of the logic that you had to deal with, and you can use like selective pieces for what you want. So imagine you're only dealing with, oh wait, let me just, if I can. Is it better? Probably is, okay. Can everyone see?
Yeah.
Okay, cool. So imagine you're only like looking to solve a specific issue, whether that be routing content between peers or like discovery. Or you just even need to deal with net traversal. Like all of these modules deal with that for you. And in like a pluggable fashion, you can use whatever suits you best, which is quite cool. So back to this. Where were we? Okay. Okay, cool. So I'm going to show you just a couple of projects that I did in order to kind of experiment mostly with the pub/sub feature of IPFS, okay? So one of them was Curvatron, which the project isn't mine. So to start with, this is an awesome project made by the Brave Bunny crew, which is like a set of people that do amazing games, usually with using Phaser.js. And this is one of those. So it's basically a snake, so like a curved snake, and I thought, so I need to experiment like this pub/sub feature. What's the best thing that I can think of to do it? A game, right? And then I looked at Curvatron and thought, this might be easy. Boy, was I so wrong. Turns out like synchronizing state between games is like a massive headache, but like really, really massive. And then when you start into like peer-to-peer games, forget it. Like just throw it all in the trash, and you know nothing. You're completely blind. There's like it's crazy. So that's why I eventually kind of gave up on it. But so there's this awesome GIF that shows what it did. So. This game didn't have multiplayer features, like it would be co-op in the same machine. So like you'd create a room, you'd share the token, you'd join, like everything's good. And then it's working, cool. I was able to test it with my brother, and he's in London, and the latency wasn't that bad. It was kind of playable. The thing is, it's really, really hard to synchronize state between peer-to-peer apps, and I started reading like a lot of stuff, and I eventually just gave up because it wasn't my main goal to build a game, and it was like really mental. I also did like a really, really small project which was like a CLI based application, which would allow you to like chat between two different machines if you needed to. It's really, really simple, not much, and feel free like to check out these projects. Like they're far from finished. Most of it was like hard coded during a night or something. But it was really cool to experience this, like, and especially the previous one, when I was able to like get multiple peers into a room. And in a peer-to-peer fashion, I was able like to synchronize state between the peers, and stuff happened, and was like, all right, I'm getting somewhere. And so that you like know why I did all of this. Oh, I did it wrong again. Sorry. So why did I do all this, and why I've been into peer-to-peer for the past, I don't know, 2 years probably. So I'm currently working on my master's thesis, which is like a pub subsystem for the distributed web. And I'll be using IPFS, and hence all the PubSub related projects, because the current implementation of PubSub in IPFS is quite naive. So the idea is that they have this API, you can build application, it's experimental of course, but it's quite naive. So whenever you're trying to deliver content in the, from the publishers to the subscribers, you just flood the network. So imagine, like, if you're a publisher, you'll send like all these messages to the network, and then eventually everyone will forward these messages, and they will just like, if I receive the message, I won't forward it. If this message means anything to me, I'll just bubble up to the application. So it's quite like, it's not a nice approach. So that's what I've been working for the past like 6-7 months, and that's what I'll be working for the next 6-7 months. Hopefully I'll be able to show you some things when I have something else good to show. But yeah, that's basically it. Thank you. I hope you're not bored to death with everything that I've told you.